All right, let's take a look at your CFU packet for chapter 2.3, where we're now going to start to use the standard normal curve to calculate out probabilities of certain outcomes when something is actually normally distributed. So the first example, you're given this information. The distribution of weights of 9-ounce bags of a particular brand of potato chips is approximately normal, with a mean of 9.12 ounces and a standard deviation of 0.05 ounces. So in part A, it says draw an accurate sketch of the distribution of potato chip bag weights. Be sure to label the mean as well as the points that are 1, 2, 3 standard deviations away from the mean on the horizontal axis. So here we go. Here's our axis. We are looking at bag weights. And so our mean, if we draw our standard normal curve, nice bell-shaped curve, send that out just a little bit, the mean was 9.12 ounces. So approximately where the curve changes curvature is the distance of one standard deviation. So we go 1, 2, and 3 standard deviations in both directions. So now we're adding 0.05 each time or subtracting. So we go 9.17, 9.22, 9.27. Then if we're subtracting 9.07, 9.02, and 8.97. So now, in the rest of these problems, we're going to use the 68, 95, 99.7 rule to answer these questions. So if you remember that, that's 1 standard deviation, 2 standard deviations, 3 standard deviations. So if it helps sometimes, what I'll tell students to do is, all right, 1 standard deviation, this is 68, middle 68%. So if I draw a line here in half, that's 34% and 34%. Half of 68 is 34 and 34. So now, if I go out 2 standard deviations, that's 95. Remember in class, we go 95 minus 68 is 27. Divide that by 2, that's 13.5%. So this area just here is 13.5%, 13.5%. So now we still have 2.5% here and 2.5% here. So if I do that same kind of process, 99.7 minus 95, that leaves me 4.7. If I divide that by 2, that's 2.35. So this area is 2.35%, meaning this is 0.15%. Same thing over on this side. I find that calculating those out or just knowing those facts make doing these problems a whole heck of a lot easier. So it says what percent of the bags weigh 9.02 ounces. So I can just look right here on the curve. I want everything going in this direction. So about 2.5% of bags weigh less than 9.02 ounces. And yes, you'll see me answering all of these with a sentence. All right, B, between what weights do the middle 68% fall in between? So that's again 1 standard deviation. Okay, so we're talking about the mean plus or minus 1 standard deviation. So in our case, 9.07 to 9.17. So we'll say the middle 68% of bags, whoops, I got ahead of myself there, sorry about that, bags fall between 9.07 ounces and 9.12 ounces. All right, Continuing on, what percent of the 9-ounce bags of this brand of potato chips weigh between 8.97 ounces and 9.17 ounces? So 8.97, so we're talking, let me choose a different color here. Let's go with, I haven't used purple yet. So we're going from 8.97 here all the way to 9.17. So if I look at that, I'm looking at all of these percentages here. So I'm going from -3 standard deviations all the way to 1 standard deviation. So basically I can just add all of these up. So if I'm looking at this, okay, I'm going to add the 34s, which is 68, plus the 13.5, plus the 2.35. So we have the 68%, plus the 13.5%, plus the 2.35%. Now that's not the only way you can get it. You could actually subtract out what was remaining. But if I actually add all those up, it gives me 83.85%. So 83.85% of the bags weigh between 8.97 ounces and 9.17 ounces. Last but certainly not least, do this last one in blue here. It says a bag that weighs 9.07 ounces is at what percentile? So basically, what percentage is below 9.07? So if I look here, 9.07, if I add those up, they should add up to 16%, so it'd be at the 16th percentile. So, go down here, a bag that weighs 9.07 ounces is at the 16th percentile. All right, let's go on to the next page. Number 2. Number 2 says use table A. So one of the things you should do right now is take out that pink worksheet I gave you in class that has table A on it. It will look like this. Okay? So as I show it to you right here for a second, you can see table A. We're going to be using this table quite a bit. So it asks us here to find the proportion of observations from the standard normal distribution that satisfies each of the following statements. In each case, sketch a standard normal curve and shade the area under the curve that is to answer the question. Use your calculator to check your answers. So I'm going to show you both methods today. So on the first one it says, all right, show me the proportion of scores that are less than negative 2.46 standard deviations away from the mean. Remember, a standard normal curve, 0 is at the mean. So I'm looking at negative 2.46 standard deviations or less. So I'm looking at that little tiny area. So now, to find this value on table A, okay, this is going to be a straight answer. Table A, what's nice about table A, remember these values in these areas, again, these values in the table represent the area, while these values going here and here is your z-score that corresponds to it. So now I'm looking for negative 2.46. So here's negative 2.4, and then this would be 2.40, 2.41, and so I'm going to go all the way out to 6. So I look at where that row and that column intersect. And they're intersecting here at 0.0069. So that's my area, 0.0069. Got my answer. Now, to show you how to do this on your calculator, you have this function called normal CDF. And if you remember today in class, normal CDF stands for cumulative distribution function. So I want to accumulate or add up this entire area. In order for you to do this, you have to type in a lower bound z-score followed by an upper bound z-score. Okay? So that's what goes inside the parentheses here. Well, the lower bound, well, this keeps on going on forever. So the lower bound is negative infinity. Right? Well, I don't have a negative infinity button on my calculator. So as we know, as we keep on going more and more standard deviations, it gets really, really close to 0. So I tell students to type in a few 9s. 3 should suffice. Then we go until negative 2.46 standard deviations. So if you take out your calculator, see here it should pop up. There it is. We've got some old stat stuff. So I'm going to go to the large screen here. We'll clear this out. So I want to enter in normal CDF. So second vars gets you to this distribution menu. So second vars, we want the distribution menu because we're doing a normal distribution. We go down to number 2, normal CDF. So then I can go ahead and type in negative 999, comma, negative 2.46. Go ahead and hit enter, and you see that we get basically the same answer. This gives you, on the calculator, the more precise answer. The table will give you it out to 4 decimal places. 4 decimal places is just fine for your results. All right, let's continue on with B. So now we're doing it being greater than 2.46. So now we're looking at, here's 0, so 2.46 and above. Now some of you might be saying, well, it's symmetric. I know that the answer is going to be 0.0069. In the end, it will be. But I want to show you that anytime you have a greater than 1, when you're using table A, what you're going to do is you're going to go 1 and you're going to subtract the area, because table A gives you this area. Table A will always give you the value less than. So what I want to do is on my table A, go to 2.46. So if I go to the other side where I have the positive z-scores, I go 2.40, 1, 2, 3, 4, 5, 6. I get 0.9931. So now, 0.9931, that's this area right here, 0.9931. But that's not the area I want. I want everything that's greater. Hence why I'm subtracting from 1. I get the 0.0069. Now, if you're doing your calculator, we're going normal CDF. Now in this case, my lower bound is the 2.46, and here now I'm going to positive infinity, so I'm doing the 999. Just to show you this one on the calculator real quick. So second bars, number 2, normal CDF, 2.46, comma, 999, close the parenthesis. And you can see you get the exact same area as we did above. All right, C. Now we're doing intervals. Or we're doing in between 2 z-scores. So on this one here, I'm going from 0.89. So if this is 0, we estimate where 0.89 is, and we estimate where 2.46 roughly is. And we're looking for that particular area. So now, what we're basically going to do, sorry, that should look better, more like a 4, is we're going to calculate out the area of 2.46 from our table, which will be everything, and then we're going to subtract out, then we'll subtract this area, leaving us the area that we want. So you have to get 2 values from table A. The nice thing is the first one is done for us, because if I go back to the last one, 0.9931 was from 2.46 or less. So I'm going to go ahead and put that one already on here, but I need to subtract out all of this area. So if I go to my table A, I'm looking for 0.89. So I'm going to scroll up here just a little bit. Here's 0.80, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's right there. 0.8133. So bring it back here, 0.8813. So if I subtract those two, I get 0.1798 as my area in between those two values. Now here's where normal CDF is actually a little bit easier. So if I go normal CDF, my lower bound, 0.89, my upper bound, 2.46. So, calculator time, second bars, normal CDF number 2, 0.89, comma, 2.46, lower bound, upper bound. Check it out, 0.179, and if we round, 8, which is exactly the same answer that we have. All right, continuing on. The last two is just more like the same. So I'm going to kind of try to do these a little bit faster. So this one here, we're going from negative 0.295, so again here's 0, to negative 1.27. So on these, table A, I'm going to take the larger area, which is going to be the negative 1.27. So negative 1, so I got to go to actually the negatives. Negative 1.27. I got to keep scrolling down here. Negative 1.27. So the 0.1020. And then I'm doing the negative 2.95. 2.95. So 0, 1, 2, 3, 4, 5. 0.0016. So I go back here, so 0.1020 minus 0.0016. So when I subtract the two, I get 0.1004. Then, if I were to do it on my calculator, I'd be going normal CDF from negative 2.95 to negative 1.27. Again, you can enter that in your calculator, and if you round correctly, that should be 0.1004. Last one is just wording it differently, but it's done in the same process. So Z is between negative 2.05 to 0.78. So it's this area right in between. So again, if I'm using table A, what I want to do is look at where 0.78 is first. So I go to my table A, I want to go to the positives, 0.78, 0.78, 0.7823, and then I want to go to negative 2.05. So negative 2.05, 0.0202. Again, I'm going to be subtracting those two values. So as I note those here, 0.7823 minus 0.0202, I get 0.7621. Again, if I'm using my calculator, that'd be normal CDF, negative 2.05 to 0.78. I should get the exact same area. All right, so number 2 is just standard. How do we use our table A? How do we calculate out areas under the normal curve straightforward? In question 3, these sometimes are the tricky ones for students, is we're doing the reverse, meaning I'm going to give you an area under the normal curve, and then you're going to find out what z-score corresponds to that value. So I'm going to show you both ways that we do this. Okay? First of all, a picture is huge and is very helpful in these problems. So I always draw a normal curve, and here it says, what is the 63rd percentile? So I want to know basically what z-score corresponds where the area to the left is 0.63. Basically 63% of the scores are below what value I'm looking for. Okay? So basically what I know is I have an area that's equal to 0.6300. I want to know what z-score corresponds to that value. So if I'm looking at table A, first of all, since I know that it's above 0.5, I know my z-score is above 0. It's positive. Because again, since the median is at 0 for z, and that's the 50th percentile, I can determine if z is positive or negative. So what I want to do is I want to go to my table A, and here I'm at the negatives. I don't want to be at the negatives, so I want to be at the positives. Now again, remember, these values here represent the areas, all these numbers in the middle. I'm looking for the one that's closest to 0.630. So as I start to scan, you can just go down one column here and start to get close to 0.630. Here I'm at 0.65 and 0.61. So I'm going to go along both those columns, and as you can see, here's where we get really close, 0.6331, 0.6290. So the question, or 0.6293, sorry. The 0 and the 3 one there, I see now that, yeah, as I stand back, when you stand really close, things get a little blurry, or it could just be my age. So now I want to know what z-score corresponds, and this is the one that I really want. That's the closest value to 0.63. Here's the 100th place of the z-score. Here's the 10th place. So my z-score is 0.33. So that corresponds to a z-score of 0.33. Now on your calculator, there is a wonderful function that does this for us also, and it's called inverse norm. Inverse norm takes an area and it converts it to a z-score. So in our case, inverse norm, my area was 0.63. So when I do that on my calculator, now you're wondering, where is that function? Well, it's in the same place where normal CDF is. It's just a couple functions down. So second pars in our distributions, there it is, number 3, inverse norm. 0.63, close my parenthesis. There we go. And we get 0.3319 if we get it a little more accurate. Either is acceptable. Okay, to get your z-score. So now, looking at B, it says 75% of all observations are greater than z. This is where you got to read carefully. So what's happening here is I'm looking for the z-score where this area, right, to the right is 0.75. But if we're using the normal curve, or I should say table A, we're always looking at areas that are to the left of it. So this isn't quite 0.25, so I'll make this a little bit better. This is the area that I really need to use for table A. So on table A, I'm looking at the area that's equal to 0.25. So area equals 0.25. How does that correspond to a z-score? Well, I know it's going to be negative, so I'm going to go to table A and look at my negative values. Here I'm on the positive, so flip over to the negatives. I'm looking for the area that's closest to 0.2500. I'm going to have to keep scrolling down a little bit. 0.24, 0.27, so as I keep going along here, you can see 0.2578, 46, 14, 83. Here's the one that's closest, so negative 0.6. If I go up to the top, it's a 7. Just to show you that it is a 7. So I get a z-score that's equal to negative 0.67. Again, I could go inverse norm of my area, 0.25, and that's going to give me my z-score. So on my calculator, I could go second bars number 3, 0.25, close my parenthesis, hit enter, negative 0.6745. So what's at least nice about these, the calculator will give you the z-score out to as many decimal places as you want, but you know, table A going out 2 decimal places is good enough for what we will be doing in this course. All right, that ends your CFU for 2.3.